Hello and welcome. In this problem, we are supposed to find the fuel consumption to accelerate this car or this truck from 0 to 70 miles per hour. The mass is provided and the heating value is provided. Heating value means if you burn 1 kg of fuel, how much heat is released. Well, we can find the change in kinetic energy, obviously. That will be delta Ke will be the kinetic energy at state 2 minus kinetic energy at state 1, which is kind of 0 because it starts from 0. And then only 20% of heat is used to produce this acceleration. So we'll divide that by 20%, 0.2, and therefore that will be the heat released, heat necessary to accelerate the truck. And from there we can find how much fuel we need because the heating value is 40 million joules. So our goal is to find the heat that is necessary in million joule. And then we divide that by 40 and we get the answer. So let's go launch the DeskCal. And initialize that anytime, that's fine. Then we start coding. So first let's write down the information that are known. Mass in kg is 10,000 and the velocity 2 in meter per second is 75 miles per hour, and I have already used the unit converter to find out 1 mile per hour is how many meter per second. That's 0.447 meter per second. So therefore, of course, velocity at 1 meter per second equals 0. So therefore, we can find delta Ke in kilojoule. Suppose we want to find in kilojoule, will be mass in kg times difference in velocity, vel2 meter per second square minus vel1 meter per second square. Of course, that's 0. Now divided by 2 is the formula we know, but then the kinetic energy will be in joule. So we have to really divide by 2000 or 2 times 1000. So what I typically say is that instead of memorizing kinetic energy as half mv square, it's better for engineers to remember kinetic energy as mv square divided by 2000. Then you'll always get the correct SI unit. Okay, so let's calculate this and see if we got the right answer. So this is the delta kinetic energy in kilojoule. So let's get the kinetic energy in million joules. Delta Ke in million joules is how much? We say delta Ke in kilojoule divided by 1000. So we need 5.61 million. We have an increase of 5.62 million joules. So how much heat do we need? Q released, or Q in kilojoule, million joule, will be delta Ke in million joule divided by 0.2, because only 20% of the heat is used to produce this kinetic energy change. So at the bottom screen you can see it's about 28 million joule. Therefore the mass of fuel in kg would be how much? It'll be the heat that you need divided by the heating value, which is 40 million joule per kg. So the answer is 0. As you can see, 0.7 kg of fuel is needed to accelerate this truck.